Hi, I'm Dion from mathsvideos.com. Now, just before I do this vector question, a word generally in a vector question on paper 2, it's actually very easy. It's probably the easiest question on paper 2. So I recommend doing it, even if you weren't really taught vectors or you're not really too confident in it, you can actually self-teach vectors very easily. And the question they ask are pretty much the exact same every year. So what we do here is, we know vectors, well, we might or might not know that vectors are very like complex numbers. And especially in one way, that when you have a complex number, is say equal to another complex number, the real parts are equal to the real parts and the fake parts are equal to the fake parts. That's the same in vectors here. So we have our I vectors are always going to, the coefficients of our I vectors are always going to equal the coefficients of our J vectors. So what we do here first is just multiply this out. So that implies that S times I vector minus 4S times the J vector plus 2t times the I vector plus 3t times the j vector is equal to 4i minus 27 times the j vector. Okay, so now what we want to do is we want to equate our terms. So we know s plus 2t is equal to 4 because the coefficients are going to equal up. So s plus 2t is equal to 4. Now on our next line here as well, we're going to have the coefficient of the j vector. It actually works out better. So it's negative 45 plus 3t is equal to negative 27. Now that implies that 3t is equal to 18. That implies that t is equal to 6. And at t equal to 6, we just sum it into this equation. At t equal to 6, we have s plus 12 is equal to 4. S plus 12 is equal to 4, and that implies S is equal to negative 8, obviously. So there we have a solution of S equal to negative 8 and T equal to positive 6. Now on the second part of this question, it's also straightforward. As long as you know your rules, and this rule is that's actually very basic. We're asked to find OQ. We're asked to find this OQ vector in terms of I's and J's. So we have to sub in our OP vector. But what I'll just show you, just remind you of this rule here, that the R vector is equal to A, I plus BJ. But then our related perpendicular vector is equal to minus B times I plus AJ. A times the J vector. So we'll just use that here. So that implies that O times the Q vector is equal to 5 times. Now, our A is going to go, our coefficient of our I vector here is going to be negative coefficient of the J vector, which is going to be 4 times I. And then our A vector is just going to move from here out to the front, which is plus 3 times J. And then we just multiply that out. That implies that OQ vector is equal to 20I plus 15J. 15 times the J vector. So that is OQ in terms of I and J. The next part here, you have to find cosine of the angle OQP. So I'll just draw you like a very bad drawn diagram here. OQP. So O is here, Q is here, and P is here. And what you want to do is you want to find this angle here. You want to find cos of the angle. So what you want to do is you want to find OQ and QP. So OQ is equal to, we have that, so we want to find QP. Well, QP vector, and this is the P vector here, because as we know, OP is the same as P. So the PQ vector is the same as the P vector minus the Q vector, or it's the same as Q vector minus the A vector. So we'll do that there, we'll find PQ vector. So PQ vector is equal to the Q vector minus the A vector. So the Q vector is equal to 20I plus 15J minus the A vector, which is, or P vector, sorry. Yeah, PQ, sorry. Minus P vector there, which is 3I minus 4J, which is negative 3I plus 4J. Negative 3I plus 4J. So So now that implies our PQ vector is equal to 17i. PQ vector is equal to 17i plus 19j. 1990j vector. So we have one vector here, and we have our other vector here. This is our Q, and this is our P, and this is our O. So we have OP, we have QP. So now we just have to remember the formula for our cosine of an angle. So we know that cosine theta is equal to, if we two lines say alpha and beta, it's equal to alpha times beta all over the modulus of alpha times the modulus of beta. So basically here is, I'll just wipe this out. I have no same screen. So our PQ is equal to that, and we have our OQ. So OQ is equal to 20i plus 15j. 20i plus 15j. Now, we multiply these two vectors here to get our top term. So that implies cosine theta is equal to the multiplication of these two vectors here, which you multiply the I terms and you multiply the j terms. And the j terms, which is 19 times 15, and it's all over the modulus of I and the modulus of j, which is the square root of 17 squared plus 19 squared times the square root of 20 squared plus 15 squared. And that works out to be, I've done this earlier, that works out to be, just to save all the maths, is equal to 5 over the square root of 26. Okay, so if you found this video useful, please add me on Facebook or Twitter, or subscribe to my YouTube channel, where I've got a lot of videos on the Leaving Cert Honours and Pass. Thanks.